Hi everyone, and welcome to this Integrated Math 2 video series. My name is Dr. Prince, and I'm the high school math specialist for Rutherford County Schools. And I will be your teacher for this online video series. This is our first video in this series, and as such, we would kind of use it as an introduction. So we'll talk about mental math, we'll talk about growth mindset, and then we'll talk about the overall structure and outlook for this course. We're going to start out though with a little warm-up. And so we've got 6 problems here behind me. What I want you to do is just take a few moments to see if you can solve these problems. If you can, use a little bit of mental math. This first time though, if you need to pull out some paper and write on there, that's fine. But at least attempt when you can to use some mental math. So take a moment to do that. All right, so let's kind of go over these 6 problems one at a time here. The first one says 2 to the third. So when we think about exponents, if the exponent is what we call a natural number or a counting number, so that's 1, 2, 3, 4, so on. So the positive integers, then we can treat an exponent as repeated multiplication. So this is just going to be 2 times 2 times 2. So that gives us 2 times 2 is 4 times 2 again is 8. So 2 to the third power is 8. So again, when it's a natural number, we can think about it as repeated multiplication. In future videos, we'll talk about what if it's not a natural number? What do we have to do then? In number 2 here, 75 minus 40, you can do this a number of different ways. You can subtract by 10 4 times, or you can just subtract 40 from the 70 and add the 5 back in. Either way, you're going to get 35. In this bottom one down here with the fractions, it looks kind of complicated because we have 51 in the denominator. But really 51, I want you to think of as our unit of measurement. And so we have 18 51sts plus 7 51sts plus 2 51sts. So we have 18 of them plus 7 of them plus 2 of them. Well, how many of them does that make it? It would be 27, right? So it would be 27 of them. It's almost like when you're saying, back in 2nd grade, 1st grade, 2 pencils plus 3 pencils is how many pencils? It would be 5 pencils, right? Well, the same thing applies here. Just 51, the denominator here, represents our unit of measurement. And so we can just add them together, and then the unit of measurement stays the same, right? 2 pencils plus 3 pencils is 5 pencils. Same thing here. All right, number 4. If we're solving this equation here, 18 plus 9 is 27. And then you can do this a number of ways. You can add 2 to both sides to keep the equivalent statement. Or you can think about, well, what number minus 2 gives us 27? And of course, that's going to be 29 minus 2. There are 6 rows with 8 chairs in each. How many total chairs are there? That's the classic definition of multiplication. We have 6 rows with 8 in each row. And so that's going to be 6 times 8 is 48. Don't forget your units. Chairs. The same thing would apply if you had 8 rows of 6 chairs each. Same concept. And then lastly here, we're going to simplify the square root of 8. So we're going to continue to do these kind of things throughout this video series. But the square root of 8, we're going to think about this for a second. 8 is not a perfect square. So what we want to do is we're going to think about, can we write this? Can we write 8 as the multiplication of 2 things or more things, in which one of those is a perfect square? So can we write this as multiplication so that one of them or more is a perfect square? So let's see, 8 and 1, neither one's a perfect square. 4 and 2, 4 is a perfect square, right? So we can write that as 4 times 2. Again, where one of them at least is a perfect square. That way we can actually evaluate that part of the square root. So square root of 4, we know that, right? We can actually simplify that. So square root of 4 is 2. So this part of the radical ends up being just 2, right? We've evaluated the radical already, so it's not inside anymore. It's now on the outside. And then this 2 here is not a perfect square, so that's going to stay inside the radical, because we haven't evaluated the radical at that point. We'll continue to work on some of that with some other examples later, but that just kind of gives you a quick idea of that. All right, so with that in mind, let's go ahead and talk about mental math, because hopefully throughout some of these problems you were able to think about it mentally. So let's think about the advantages to mental math, and those are listed here. Some of those include, helping you in learning math. If you're not stuck on the number manipulation when learning in class, then you can focus more on the integrated two concepts. So, for example, if you're not stuck on 75 minus 40, you can go ahead and think about that mentally. Then you can think about the algebra that's involved, for example. Calculating tip or sales price. If you walk into a store and you want to calculate the sale price of an item that's maybe 20% off or something, you can do that pretty quickly. Or calculating tip, whether it be 15% or 20% or whatever it may be. Estimating costs. So let's say you are checking out at a store and you've got 4 or 5 items. You probably should have at least an estimate of how much that's going to cost. And if it varies a lot from that amount, then something didn't check out right. And so you can ask the cashier, maybe what happened. And then on ACT is 60 minutes, 60 questions. You want to maximize your time on the ACT. And if you can just trust yourself that 3 times 5 really is 15, and you don't have to type it in the calculator every time, those are going to be some valuable seconds that add up over the course of the test. And then lastly, number sense and reasoning. If you can make sense of some of the problems that are involved within integrated 2, and know when something didn't go right, then you can always go back and fix it. And so that this can help with that as well. So that's kind of the importance of mental math. We'll continue to do some examples each session as we go throughout this video series. All right, so the other thing that we wanted to mention today is the value of a growth mindset, having a growth mindset as you enter integrated 2. So here are the benefits and the key points to a growth mindset. One is you can learn math. Everyone can be successful in mathematics. For some, you may have had some bad experiences in math class. You all come in with varying backgrounds, but you can all be successful. With the right effort, with the right mindset, you can be successful. You can learn it. There's no such thing as a math person. You might think that you're fixed in this I can't do math stage, but you're not. You can grow and you can change and you can get better. It's not a gene that's passed down from your parents. It is something that you yourself can be successful in. And don't compare yourself with others. If you're not the fastest person to finish a test, or if you're not the quickest to think about a math problem, that doesn't mean that you're any less capable than others. That just might mean that you think slower but maybe deeper about the mathematics. And so that's okay. As you'll see in the video here in a minute, there's a famous mathematician that was one of the slowest kids in his class. Again, that doesn't mean that you're not capable. Effort, growth, and perseverance are keys to learning. Again, that's what it takes, and you can do it. And then lastly, we learn more by making mistakes than we are by being successful. So if you don't do well on a quiz or test, you just haven't mastered that yet. All right? But you can learn so much by your mistakes. So just treat that as an opportunity to learn. All right, so at this time, I'll turn it over to the folks at Stanford, and they're going to explain more about a growth mindset. All right, everyone, welcome back. Hopefully you enjoyed that video from the folks at Stanford on growth mindset and the power of yet, and how if you don't have something, you just don't have it yet. So with that, let's also look at some other things here. So one thing to keep in mind is the value of everybody's solution method. And so if you look at this pattern here, you all might approach this a little bit different ways. So if we want to count the stars in each of these steps, and then maybe predict what the next step would look like, you might all, again, approach it differently. So for this first one, some of you might see that the step numbers, this is step 1, 2, and 3. So the step number is up above, and then the horizontal row here is the step number plus 1. So 1 and then 2. step 2 with 3 below, step 3 with 4 below, and so on. So the next one would be step 4, so it would be 4 above, and then 5 below, so making 9. So you might have predicted that already. Others of you might have just counted every star. So we got 3, 5, 7, and then maybe 9 from there. Others of you may have seen that we have 1, 2 plus the corner. So 2 plus the corner is 3. 4 plus the corner is 5. 6 plus the corner is 7. And the next one would be 8 plus the corner would be 9. So really it's the even numbers starting with 2 plus 1 as you go throughout here. So again, just a variety of ways to approach this problem. And so as you go throughout this year, really appreciate the methods that your classmates take in solving problems. So at this time, we're going to go ahead and look at the overall structure of this course. So when you think about Integrated 2, here are the main topics that we're going to cover this year in Integrated 2, starting with piecewise functions and absolute value functions, which is a type of piecewise. And then we'll get into quadratics, and I bolded quadratics because it is such a huge topic. So really after absolute value is the rest of the first semester. So a huge topic in Integrated 2. And then when we come back next semester, we'll look at rational exponents, and we'll talk about what that means. Exponential functions, and we'll get into some geometry, and we'll talk about how do we know that two figures are similar, meaning they're the same shape, but not necessarily the same size. And then we'll talk about surface area, volume, and then lastly, we'll end with some probability. So that's kind of the outlook for the year of Integrated Math 2. The last thing I wanted to share with you before we go is while you're working through these Play Pause It videos, if you get to a screen that asks you to do a Desmos activity on the side. So there's going to be things popping up, as you've already seen in these videos, to ask you questions and different things. But there could be like a Desmos activity that pops up. And I just want to make sure that you notice one thing here. So there is an X here, and then there's an X there, and you're not sure maybe which one to press. So let me show you real quick. When you're done, you will click this X right here, the top one. So not the one below. So click the top one to exit out of the Desmos activity. So, all right. So with that, that concludes our very first video in Integrated Math 2. We look forward to seeing you in the next session. But for now, we'll say goodbye.